basic dimensional formulas. You know, mass is represented by capital M in dimensional formula. SI unit is kg. Length is represented as L and SI unit is meter. Time is represented as capital T and SI unit is seconds. Okay, so this MLT forms the basis of all dimensional formulas. Apart from that, you have temperature whose SI unit is Kelvin, and this dimensional formula is also Kelvin. So these are all secondary, okay, but you should know MLT. And regarding theta, angle theta is dimensionless. This has got no dimension, dimensionless. Whereas its SI unit will be radians. You know, the angle can be measured in terms of radians. So these are this is dimensionless. You got to remember this. And temperature is merely Kelvin. And this mass, length, and times form the basis of everything. Okay, let's see if supposing I'm going to talk about velocity. The formula is distance by time. So which is L by T. So it's LT to the power minus 1. That's a dimensional formula. SI unit is meter per second. Acceleration is velocity by time. Velocity itself is LT to the power minus 1 by TT, which makes it LT to the power minus 2. That is meter per second square being the SI unit. Okay, force. Force is equal to mass into acceleration. So you already have acceleration here. So it's just a question of MLT to the power minus 2. And the SI unit is Newton. So that's force is done. You can also talk about momentum. Momentum is represented by P, small p, okay, which is mass into velocity. And mass is m, velocity is LT to the power minus 1. So then momentum is kg meter per second. That's the SI unit. That's about momentum. Then it's about, since you wrote force, we can write work done. Work done is force into displacement. And force itself is MLT to the power minus 2 here. And so multiplying and displacement L with it, it will become ml square t to the power minus 2. And work done is SI unit is in joules. Okay, then it's about power. Power is the rate at which work is done. Power is the rate at which work is done. Sorry about my bad handwriting. Work done is already ml square t to the power minus 2 by t. Therefore, the dimensional formula is ml square t to the power minus 3 is power's dimensional formula. Okay, and you know the SI unit is watt. That's about power. Then is about pressure. Pressure is force by area. Pressure is force by area. Force is mlt to the power minus 2 by area is L square. L into L, L into B, which is all dimensions is length and length. So it's ml to the power minus 1, t to the power minus 2. And SI unit is Pascal. Newton per meter square, which is Pascal. Okay, so that's about pressure. And next is, let me talk to you about some rotational motion. The rotational motion, you should know that there's something called a torque. Torque is also known as moment of force. Moment of force, that is a force in a rotational motion, which is force into perpendicular distance. Okay, so force is mlt to the power minus 2 into distance is L, so it's ml square t to the power minus 2. I'm just recalling the work done also had the same dimensions. So the two physical quantity which has the same dimension can be classified as work and torque. Okay, so that's about torque. Torque is a force in a rotational motion, as you know. Next is in the rotational motion, I want to teach you this is moment of force. I'm going to teach you moment of inertia. Moment of inertia. Moment of inertia is represented by I, which is mr square. Mass into distance square, mr square. So then what will be the dimensional formula is ml square. There's no t, so you can write t to the power 0. So therefore you can write it as m to the power 1, l to the power 2, t to the power 0. But however, we can leave it like that, ml square for now. That's about moment of inertia, I is equal to mr square. Then it's about gravitational constant. So these are the three, okay. On a rotational motion, I'm talking to you about torque, I'm talking to you about moment of inertia. Let me also talk to you about angular velocity. When it comes to rotational motion, there'll be angular velocity, which is omega, which is angular displacement by time. As you know, there's no dimensional formula for angular angle, and there's only t, so t to the power minus 1. Okay, that's a dimensional formula. So you can also write m to the power 0, L to the power 0, t to the power minus 1 if you want. Okay, that's about angular velocity, which is represented by omega. Then is angular acceleration. Angular acceleration is alpha, which is omega by t. Angular acceleration is represented by alpha, which is angular velocity by time. Omega itself is t to the power minus 1 from previous, and t to the power minus 1 by t, it will become t to the power minus 2. Therefore, you can also write it as m to the power 0, L to the power 0, t to the power minus 2, or leave it like that as t to the power minus 2. That's about angular acceleration. Then you know that a time period, time is represented by capital T, and here reciprocal of time period is called frequency. So in a rotational motion, you'll also have frequency, which is number of oscillations per second. So then therefore, it's a reciprocal of time period. And so it's t to the power minus 1. As the SI unit is hertz, okay, for that matter, the moment of inertia, SI unit will be kg meter square, because it's kg and r square, m and r square. That's the SI unit. In this angular velocity, it will be radians per second. Radians is SI unit for theta and per second. That's the I'm talking about SI units. Angular acceleration, this is radians per second, so it will be radians per second square, because acceleration, radians per second square. And here it's hertz is the SI unit for frequency, which is just t to the power minus 1 in terms of dimensional formula. Okay, so these are the things which is to do with rotational motion that you are supposed to know. And then we can also talk about angular momentum. Now that you will be familiar after attending my class with the word angular momentum is represented by capital L, which is like a linear momentum. You know, linear momentum is mass into velocity, but here angular momentum is r times linear momentum. So then it's r times m into v. So let's like the dimensional formula. R is L, m is m, velocity is L t to the power minus 1. So it's m L square t to the power minus 1. That is the dimensional formula for m L t to the power m L square t to the power minus 1, which is angular momentum's dimensional formula. SI unit will be obviously angular momentum is r into p. R into p, this momentum is mass into velocity, which is kg meter per second. So kg meter square per second. That will be the SI unit. SI unit is not important. What is important is to understand dimensional formula. SI unit is basics. You should have already known all this, so I'm just recalling those formulas. That's about angular momentum, and these all comes in rotational motion. Okay, when these roll in rotational motion, I'll also teach you what is Planck's constant. Planck's constant. That will come in energy is directly proportional to frequency of the incident radiation, and energy therefore is equal to h mu, where h is known as Planck's constant, and h can be written as E by mu. So E is nothing but energy, which is also work done by mu. Work done dimensional formula is ml square t to the power minus 2 by frequency is t to the power minus 1. So when you take it up, it will become t to the plus 1, so ml square t to the power 0. So this is the unit for Planck's constant. It's just Planck's constant is h, which is E by mu. Okay, sorry, it's frequency itself is 1 by t. When you take it up, it will be t. Work done is ml square t to the power minus 2. I made a mistake here. ml square t to the power minus 2 by t to the power minus 1 is ml square t to the power minus 1. I'm sorry, just please correct it. ml square t to the power minus 1 will be Planck's constant. So made a mistake. So work done is ml square t to the power minus 2 by frequency is t to the power minus 1. So you'll get this Planck's constants h. Okay, that apart, what did I teach you in the class is about when it comes to solids. There's something called stress by strain. What is stress? Take a spring balance and add weights to the pan. The spring will get extended by delta L, and the original length is L. Change in length by original length is what is called strain. And that is happening because you're applying a force, and there is a force by unit area, which is nothing but stress. The same as pressure, But when it comes to solids, we call it a stress. And the ratio of stress by strain is what is called coefficient of elasticity. Coefficient of elasticity, another word for it is Young's modulus of elasticity. Young's modulus of elasticity, which is also represented by Y, Young's modulus of elasticity, stress by strain. You all know stress is force by area. You can write the dimensional formula for force is ml t to the power minus 2 by area is L square. Strain is change in length by original length, so it has no dimensions. L and L will get cancelled. Therefore, your coefficient of elasticity has the same dimension as just stress, which is ml to the power minus 1 t to the power minus 2 from here. So that's got the same dimensions as stress. So ml to the power minus 1 t to the power minus 2 is the same as pressure also. So if they ask you name two physical quantity which has the same dimension, we can also say coefficient of elasticity, and stress has the same dimension because strain do not have any dimensions at all. Dimensionless quantity. So what are the two dimensional quantities that you know? Theta is a dimensional quantity. Strain is a dimensionless quantity. These are all dimensionless quantities. So that's about coefficient of elasticity. This is when it comes to solids. I hope you understood. Then is about liquids. Liquid. I taught you a word here which is called surface tension. A surface tension is a force on the surface of the liquid, which is force per unit length, which is ml t to the power minus 2 by L. L and L get cancelled. M t to the power minus 2, or in other words, m to the power 1, L to the power 0, t to the power minus 2. That's surface tension. Then is surface energy. Surface energy. What is surface energy? Take the surface tension's formula, multiply and divide by L. This will become work done, force into displacement. This will become L square, which is nothing but area. Work done by unit area is what is surface energy. Work done's formula is ml square t to the power minus 2. By area is L square get cancelled. You still get the same formula. Surface tension and surface energy, both of them have the same dimensional formula, m to the power 1, t to the power minus 2. The dimensional formula does not change. So name two physical quantity which has the same dimensions. Again, you can talk about surface tension and surface energy. Surface of the liquid has got surface tension, a tension which is due to the unequal forces acting on it. Because on the surface, the molecules are attracted by the molecules of water. On above, it's air, so unequal forces. So there'll be a tension and the upward pressure will be more. So because of which the water will start rising. And that's a phenomenon which is called capillary rise. Anyway, we're not going to deal with it now. That's happening because of the tension on the surface, and that's force per length. This is happening in the case of liquid. The other point that I would like to tell you is take a ketchup bottle. The ketchup bottle, if you're buying a pizza, try to pour the ketchup bottle on the pizza. It will not flow. You have to heat it. Only then it will start flowing. So that is called, that's due to, I'll tell you what, this is a nozzle of the bottle. The ketchup bottle or honey you take, for example, is going to pour out like this. Every layer, the bottom the bottom of the nozzle is going to pull back the above layer. This layer. And this layer will pull back the next layer. The next layer will pull back this layer. This layer will pull back this layer. Such a pulling back is called friction in fluids. Friction in fluids. And that's called frictional force, or in other words, viscous force. The viscous force is a frictional force in fluids which is happening between various layers. And so the honey will not even drop down. It'll be just hanging at the nozzle. The viscous force is directly proportional to the area of contact, because there's so much area which is getting pulled back by another. Also, each layer is having with velocity v1, depending on the position, is x1 from the base. This will travel with the velocity v2, depending on the position being x2 from the base of the nozzle. This will travel with the velocity v3, the position being x3. So then for every position from the base of the nozzle, you're having different velocity. There's a variation in velocity dv with variation in position, which is called dx, difference in velocity by difference in x, dv by dx. It's also known as delta v by delta x, a variation in velocity by variation in position, a dv by dx. And the viscous force is directly proportional to dv by dx. It's directly proportional to A, it's directly proportional to dv by dx. Let's call the viscous force as F. which will be equal to eta into A into dV by dx, where eta is known as coefficient of viscosity. Coefficient of viscosity. Viscosity. That eta is F by A into dV by dx. That eta is F by A into dV by dx. So then what is it? It's about F, which is ml t to the power minus 2, by A is L square, velocity is L t to the power minus 1, by X is L. Okay, L and L get cancelled, take it up, m L to the power minus 1, t to the power minus 1. Very, very important. They'll ask you the dimensional formula for coefficient of viscosity. How did it come? I'm teaching you the basics of the physics. When I catch a bottle, the ketchup will not flow. Each layer will pull back another layer. So each layer is having different velocity with respect to the position. That's called dV by dx. It's also known as velocity gradient. It's known as velocity gradient, another word, which is dV by dx. So viscous force is directly proportional to area of contact and directly proportional to velocity gradient. Viscous force is equal to eta into A into dV by dx, where eta is known as coefficient of viscosity. Eta is equal to F by A into dV by dx. And so you can fill in this. Okay, I hope you all understood. So that's about coefficient of viscosity. So let's go to, these are all about fluids that you're supposed to know. The three things that in fluids is surface tension, next is surface energy, and next is the coefficient of viscosity, for which you should know what is the viscous force, the frictional force which is exerted on a fluid between various layers. And it depends on the area of contact and velocity gradient. So when proportionality is removed, you get a proportionality constant, which is eta, which is what is known as coefficient of viscosity. They ask you what is the formula for coefficient of viscosity? Is viscous force by A into dV by dx by area into velocity gradient. You should know this. Very, very important. Apart from that, I also would like you to know generally these things, which is density is mass by volume. M by L cube. So M L to the power minus 3. Volume is L into B into H. All of them are length only. So L to the power 3. So M L to the power minus 3. T to the power 0. You can write. That's density. That's something I didn't mention before. I want to clarify that now. Then I also would like to specify, you know what is angle? Angle is theta. And from last year's portion, you know theta is equal to L by R. Arc length by radius. Theta is equal to L by R, provided theta is in terms of radians, and we want theta in radians only. L by R. And so no wonder length and radius is both L and L, it's getting cancelled. That's the reason theta is becoming dimensionless. An explanation as to why theta is becoming dimensionless. Okay, then is about what is, I think that this should be enough for now. You become clear till here. You become very, very clear till all this. And once you're thorough, I'll teach you next class, okay? I also did basics such as, today what did I do? Is I'll just recap those sums that I did today. The things that I do today is a application of dimensional formula. The first application being conversion of one system of unit into another system of unit. Supposing I want to convert 1 joule to 10 to the power 7 erg, how do I do that? Write it as N1 U1 is equal to N2 U2. You know this one stands for SI, this one stands for CGS, and you want to get the answer in terms of CGS. Then you write N1 M1 L1 T1 to the power ABC is equal to N2 M2 L2 T2 to the power ABC. So you want to get the answer in terms of CGS, so write N2 is equal to N1 into M1 by M2 to the power A, L1 by L2 to the power B, T1 by T2 to the power C. And this is about work done, joules, whose dimensional formula is ml square t to the power minus 2, from which you know A is equal to 1, B is equal to 2, C is equal to minus 2. Come back and substitute that here, before which you know what is in the denominator is all CGS. What is in the numerator is all SI. The whole point is you want the answer in terms of CGS. So N1 into 1000 M2 by M2 to the power A, 100 L2 by L2 to the power B, and time, whether it's CGS or SI, it's going to be seconds and seconds only. So seconds and seconds will get cancelled. You don't have to bother about it. Is equal to N2. But you know what is A and B is 1 and 2. So replace here 1 and replace here 2. L2 get cancelled. M to get cancelled. N1 into 10 to the power 3 into 10 to the power 4 is N1 into 10 to the power 7, which is N2, and thus you got it in terms of erg. So 1 joule is 10 to the power 7 erg. Okay, so you got it. Okay, next is how to convert 1 Newton into 10 to the power 5 dyne. You know, this is SI, this is CGS. And you know that N1 U1 should be equal to N2 U2. N1 into M1 to the power A, L1 to the power B, T1 to the power C is equal to N2 into M2 to the power A, L2 to the power B, T2 to the power C. You want answer in terms of CGS? So N2 is equal to N1 into M1 by M2 to the power A, L1 by L2 to the power B, T1 by T2 to the power C. So then you're gonna think of converting all the SIs into CGS here. Okay, so then this is CGS already, so it does no conversion. N1 into 1000 M2 by M2 to the power A, 100 L2 by L2 to the power B. Okay, and T1 and T2 are always in seconds. You can ignore that, is equal to N2. What is A and B? This is force. Force is MLT to the power minus 2, which shows that A is 1, B is 1, and C we're not bothered because time. So A is 1, B is 1, just replace it as 1 and 1. So you get N1 into 10 to the power 5 is equal to N2. That shows that 1 Newton is equal to 10 to the power. Thus you proved 1 Newton is equal to 10 to the power 5 dyne. Okay, so that's completed. I also did a few sums today in the class. I'll just repeat those sums. Okay, you can copy the questions if you want. How to convert a 6.67 into 10 to the power minus 8 dyne centimeter square per gram square into SI unit. I don't need N1 U1 is equal to N2 into this is 10 to the power 5 dyne. 1 dyne is 10 to the power minus 5 Newton. Centimeters 10 to the power minus 2 meter, whole to the power 2. Gram to kg is 10 to the power minus 3, the whole to the power minus 2. So it will be 10 to the power minus 5 into 10 to the power minus 4 into 10 to the power 6. And this will be 10 to the power minus 9 into 10 to the power 6. This will be 10 to the power minus 3. Bring this in 6.67 into 10 to the power minus 8. That's your N1 or whatever. So then therefore it's 6.67 in 10 to the power minus 11. And Newton will become, dyne will become a Newton, centimeter square will become a meter square, a gram square will become, per gram square will become per kg square. Direct conversion, there's no need to write N1 U1 for such sums. Okay, so let's go to next sum. I taught you another sum here today, which was like a 60 joule per minute has to be written as a new system of unit, which has got base units as 100 grams, 100 centimeter, and 1 minute as the base unit, as base units. So you have to convert this into this. The moment I see this, I want SI. Okay, so 60 joule per minute is 1 joule per second. So this is nothing but power. And we know the dimensional formula for power. Power is the rate at which work is done. M L square T to the power minus 2 by L, which will be M L T to the power minus 2. So A is 1, B is 1, C is minus 2. So you understand what is A, B, and C. A is 1 ml square by T. Sorry, I made a mistake here.